Pre-Calc students, welcome to today's lesson on solving right triangles. So the title says Solving Right Triangles Review because this is something that you guys have possibly studied already multiple times in your math career. So again, the main focus is on right triangles. So don't forget that this is key, okay? Everything we're going to discuss today has to do with right triangles. Now, this unit in general is about trig. Okay, so trigonometric functions like sine, cosine, and tangent. There are a couple more, but we'll discuss those later on. When you are looking at a right triangle, okay, it is important to know how to name the different pieces of it, okay? So across from the 90-degree angle, no matter which way the triangle is drawn, okay, the side that is across from the right triangle is always called the hypotenuse, okay? So we represent that with the letter H. Now, whenever you are given a right triangle, besides the 90-degree angle, there's always two other angles, right? Because there's three angles in a triangle. In this case, I've labeled theta, so it's a Greek letter, theta, as my angle that I'm concentrating on. Okay, so whenever you're dealing with trig functions, they always require you to focus on one angle at a time. So if you notice in this triangle that I drew, theta is the angle that I'm concentrating on. Now the hypotenuse is always a hypotenuse. The hypotenuse is across from the 90-degree angle. But once you focus on a specific angle and you look opposite of it, we consider that the opposite leg. We represent that side with the letter O. The side that is next to it is considered adjacent. Now, technically, there's two sides that make up angle theta, right? There's two sides next to it, but one of them is the hypotenuse. So the other one you call the adjacent leg. You guys have been exposed to something called SOHCAHTOA. My computer gets a little jumpy sometimes, guys. Bear with me. Okay, so SOHCAHTOA, okay, it depends on who your teacher was and how they wrote it out, is pretty much the explanation of the three basic trig functions, right? Again, some of you may have just learned it like this. Now, SOHCAHTOA describes the relationship between the sides of a right triangle and the angle that you're looking at. So when you are talking about a specific angle, you can describe, so the abbreviation for sine is SIN. So the sine of that angle is a ratio. So the sine of the angle is a ratio. It includes the opposite leg over the hypotenuse. The cosine of an angle is represented by the ratio, a fraction, of the adjacent side to that angle over the hypotenuse. So notice both sine and cosine have hypotenuse in the denominator. And finally, the tangent, which is abbreviated with TAN, the tangent of an angle equals the ratio of the opposite side over the adjacent side. Remember that adjacent means next to. It is important for you guys to make sure you're pronouncing these correctly. So when you read this, you don't say sin of theta or cos of theta, tan of theta. Make sure you practice saying the whole trig function out loud. Sine of theta, cosine theta, tangent of theta. Okay? And it's important for you to also realize that the trig function is always followed by an angle. Then it equals a ratio, a fraction. Okay? So that's the order. The sine of an angle, cosine of an angle, or tangent of an angle, all equal ratios. Okay? They all have different ratios that correspond to them. We are going to practice solving right triangles. What does that mean? So solving right triangles is pretty much like finding all the missing pieces of a triangle. So in a triangle, I might give you a couple pieces of information about it, and you have to find the rest. So you're going to use pretty much everything you've learned about triangles in the process, including these three theorems and properties. All the angles in a triangle add up to 180. You're going to use inverse trig functions. So sine inverse, cosine inverse, tangent inverse. Remember that when we studied inverses, we say that another way to write inverse for f of x was to write it as f of -1 or f to the -1 of x. That was the f inverse, the inverse of f. So inverses are sine inverse, cosine inverse, and tangent inverse. And the Pythagorean theorem, which says that the two legs, when you square them and add them, are equal to the hypotenuse squared. So a squared plus b squared equals c squared. All of these, including any given information, is what you're going to use to solve the right triangle, okay? Now think about it. A triangle has 3 sides, 3 angles. You need to make sure when you are solving that you have found the value of every single side and every single angle. Before we start, though, it's really important for you guys to notice that your calculator needs to be in degree mode, okay? So I want you to check your Chromebook if you're using your Chromebook calculator or your personal graphing calculator. You're going to click Mode, which is the button next to the second button. So you're going to click Mode, and you're going to need to scroll down where it says radian and degree. You need to select degree, so put your arrow over degree and push enter. You need to click enter so that it highlights degree. So when you're dealing with right triangles, we're talking about all the sum being 180 degrees. So we'll discuss radians later on, but for anytime you're dealing with right triangles, your mode on your calculator needs to be in degree. Okay. Now, one of the biggest pieces of advice that we're going to give you is to please, 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 whenever possible, okay, use the given values. Don't use the ones you have found. For example, let's say we were given one angle, you found another one. Use the given angle to set up your ratios and your trig functions, okay? Always try to use the values that you were given, not the ones you have found along the way. How come? Because sometimes we make mistakes, right? You might have found a missing piece, and if you use that value to set up a new equation, then you're kind of like doubling your mistake, okay? So when you're setting up your equations, try to use the given information, not information you have found. All right, so let's just start off nice and basic. Let's just find one missing piece at a time, okay? Now, for this lesson, I want you to round your sides to the your side lengths to the nearest hundredth, so that's second decimal, and your angles to the nearest tenth, okay? So round it to 2 decimal places for the side lengths and angles to 1 number behind the decimal. All right, so number 1, we are missing a side length of x. Your theta, or your angle, is 48. So to find the side, I'm going to create an equation that sets up the use of x and 29 and the angle given. So compared to this angle, I've got the hypotenuse, right? The hypotenuse is always across from the 90 degree. I do not have the opposite side. So the opposite side is missing. We don't know what it is. Remember, opposite is across from. But we do have a label for x for the adjacent. Okay, so we don't have an opposite, so we don't have an O. We do have the hypotenuse, and then here we're dealing with the adjacent, okay? So we are going to, using the hypotenuse and the x, which is the adjacent side, HA, right? If you think of SOHCAHTOA, that means if you're going to use H and A, you're using cosine. So I'm going to set up my equation. Cosine of theta, which is 48 degrees, equals adjacent over hypotenuse. So adjacent means next to. So the side next to it is x. The hypotenuse, remember, the hypotenuse is always across from the 90 degrees. Okay? So the hypotenuse would be 29. Okay. Now, you can solve this as a proportion, which is what I tend to do. So what I do is I just put a little 1 under cosine of 48, and then I cross multiply. Or what you can do is just multiply both sides by 29. So it's up to you, okay? But you'll see why I use proportions in the next example. Again, I'm going to put a little 1 here. I'm going to solve this as a proportion, like this, okay? Or you can just multiply both sides by 29. So 1 times x is x, and then I'm going to multiply 29. I'm going to put that in front. I like to keep my single values, like 29, in front of my trig functions. That's just a recommendation on my part. So most calculators have parentheses around the angle. So just check the calculator, right? Let me see what the Chromebook does. Cosine, so 29 cosine of 48. Yeah, so mine, it comes up with parentheses. Now what you don't want to do, okay, is you don't want to do cosine of 48 and then times 29, because then it's going to take the cosine of whatever 48 times 29 is, and you don't want that. Okay, so no. You want to do cosine of 48, close the parentheses, times 29, or put the 29 out in front, and then multiply with the cosine of 48. So you see how the first and the third answers are similar, or are the same, 19.404, blah, 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 but the middle one is not. So be careful. Remember, the calculator is only as smart as its user. It does what you tell it to. Okay, so we have set up a proportion, right? I solved it as a proportion. Remember, you could have just multiplied by 29, and then we get an answer of approximately, well, we were finding a side. I want sides rounded to the second decimal, so that's 19.40. If we had units like inches or centimeters, then you would put the appropriate units. All right, so now I'm looking at a different angle and a different right triangle. I'm looking at an angle of 74 degrees. Remember, the hypotenuse is always across from the 90 degrees, right? So that's the hypotenuse. I was not given the hypotenuse. I've been given x and 5. So I have to ask myself, what are those compared to the angle? Are they definitely not the hypotenuse, right? We've got opposite, or you can just use the letter O, and adjacent, which means next to. So according to SOHCAHTOA, opposite and adjacent require us to use tangent. So I'm going to set up an equation. The tangent of angle of theta, which is 74 degrees, equals opposite, so opposite, over adjacent. So opposite over adjacent. Remember, those are the ones we're using. This one goes on the top. This one goes on the bottom, the denominator. So this example is the reason why I solve things as proportions. I put a little 1 under tangent of 74, and then I cross multiply. Because if not, if you don't do it that way, then you have to multiply both sides by x to get the x out of the denominator, and then you're going to have to do one extra step by dividing both sides by tangent of 74. So I'm just going to show you super fast. You can multiply both sides by x to get the x out of the denominator, and then you'll have to divide by tangent of 74 to get the x by itself. So it's not as simple as the original problem we did, where it was x over 29 and you just multiplied both sides by 29, okay? When your x is in the denominator, there's a little more involved. So what I like to do is I just like to cross multiply, so set it up as a proportion. So then I have x times tangent of 74. Remember, I like to keep the single part of it in front and then my trig function, so tangent of 74. And I keep forgetting to put my little bubble for degrees. Always keep your units. Equals 1 times 5, and then divide by tangent of 74. Both sides. And that's 74 degrees. That's why you need to make sure you're on degree mode. So x is approximately take a minute, put that in your calculator, pause the video if you need to. Remember, we're finding a side length, so you need to round to the second decimal. Okay, just want to remind you that when you set up your ratio, right, opposite over adjacent, adjacent over hypotenuse, if your x is in the denominator, it's not just multiplying both sides, for example, here by 5, okay? When your x is in the denominator, it requires a little bit more work solving than if your x was in the numerator, like in example 1. So be careful, watch out for that. Now this next one is missing the angle, okay? So whenever you're finding the angles, that's when you're going to use inverse. So for finding the angle measure, that's the only time that you're going to use the inverse. Okay? You don't use inverse operations for finding sides. Okay, so our theta in this case, we'll call it x, right? This is our angle that we're missing. We've been given opposite and the hypotenuse. Remember, the hypotenuse is always across from the 90-degree angle. All right, so opposite and hypotenuse involves sine, right? So for SOHCAHTOA, sine is the one that requires the use of opposite and hypotenuse. So I'm going to set up sine of x, we don't know the degrees, equals opposite over hypotenuse. Now, sine is an actual, like, operation. When you take the sine of an angle, it does something to it. So the same way, you know, if you were adding something to x, you would have to cancel the addition with subtraction. If you're taking the sine of x, you have to cancel the sine with the inverse sine. So essentially what you're doing is you're taking the sine inverse, because that is going to cancel, and you do it to both sides. The sine inverse cancels the original sine that was there. Okay, but obviously what you do to one side, you've got to do to the other. So sine inverse and sine cancel, and you're left with x. We don't know the degrees, right? And then in your calculator, you're going to find the inverse sine of 8 over 17. So how do we get the inverse? Well, sine, right, is obvious. You're going to push second sine, sine inverse of 8 over 17. And then push enter. Remember, angles, you need to round to the first decimal, so that's going to round to 28.1. 28.1 chickens? 28.1 degrees. Okay? So make sure that you guys are putting the correct units in your answer. Okay? Don't forget the units. We're going to take off points if you forget the little bubble for the degrees. So that's how you find a single missing piece. Now we're going to be looking at how to solve an entire triangle. Okay, so that means you need to find all the missing pieces. So essentially we're trying to find x, y, and z. What I like to try to do is that when I'm given one of the angles, I use the 180 rule and just find the missing one. So according to the rule of 180, right, to find the measure of angle z, all I have to do is take 180 and subtract the two angles that were already given, which are 53 degrees and 90. Okay, so if I subtract those from the 180, that'll give me the value of z. So 53 plus 90, and then subtract that from 180. You could also write it like this, guys. 53 plus 90 plus z equals 180, right? Add 53 plus 90 and then subtract from 180. Whatever makes more sense to you. All right, that's going to give me 37 degrees. So I have officially found z. Now I'm not going to fill it into my triangle because remember, according to my my own advice. I try not to use any values that I've found to help me find the rest of the missing pieces. I'm going to just leave the triangle as is and keep using the written information that was on the triangle, not information that I found. So just in case I did something wrong, subtracted wrong when I found angle Z, I don't want to use that value in the rest of the setups for my equations. Okay, so I'm just going to go in alphabetical order here. It really doesn't matter, guys. But let's say I want to find x, okay? If I want to find x, I'm going to ask myself, how is x related to theta? So theta is 53. Well, it's the adjacent. Now, I have two other sides that I can work with, but if I use x and y, then I'm going to have an equation with two variables in it. When you set up your equation, you want to have only one variable in your setup, okay? So you're going to have, for this one, I'm going to use adjacent and hypotenuse. Okay, again, I did not choose to use adjacent and opposite because then I'd have two variables in my setup. All right, adjacent and hypotenuse is cosine. So cosine of 53 degrees equals adjacent over hypotenuse. You can just multiply both sides by 10 or cross multiply, and you get 10 times cosine of 53 degrees, which rounds to 6.02. So there's x. All right, so now I'm going to go back and use my 53 degrees, but instead of using x, I'm going to use y to find the value of y. So to find y, I'm going to use, so if I use y is the opposite, right? Opposite from the angle. So now I'm going to use sine because sine requires the use of opposite over hypotenuse. So sine of 53 degrees equals opposite over hypotenuse. That's supposed to be a y, sorry. I can multiply both sides by 10 or I can cross multiply. Remember I told you you could put the little one under. Pew! Either way, you're going to have 10 times sine of 53 as the value of y. So 10 times sine of 53. Remember, I like to keep that single value in front of my trig function. So the 10 I'm going to always put in front. And that'll give me approximately, go ahead and remember, you guys should be practicing on your calculator. So if you feel like I'm going too fast, remember, you can pause. You can pause the video. This gives you 799. So that's the exact answer and the rounded answer. Not too bad, right? So when you're given two angles technically, right? Because the 90 degrees is a freebie. When you're given two of the angles, finding the third one should be easy peasy. You just subtract the two angles that you were given from 180, and whatever's left over is your answer. The important thing, guys, is when you're setting up your trig equation, you should only have one variable at a time that you're trying to find, okay? You never want to set up an equation where you have two variables in one. All right, so unfortunately for number 5, I can't use the 180 rule because 90 degrees is the only angle that we have, and that's not enough for me to figure out what the rest are, okay? So I can't use the 180 rule. But what I can do is I have noticed that I was given two of the sides, okay? So in the previous problem, I was given two angles, so finding the third angle was easy peasy. Here, I'm given two sides, so finding the third side should be easy peasy. Whenever you're given two of one thing, so two sides or two angles, I like to do that first. So I'm going to go ahead and find the missing side. Again, if you would rather solve this in alphabetical order and find x first, go for it. All right, so the Pythagorean theorem says that the two legs squared and added will equal the hypotenuse squared. So remember, the hypotenuse is across from the 90 degrees, okay? So this is my hypotenuse. All right, so according to the Pythagorean theorem, right, if I solve this, and then subtract, and then square root. Normally we would put plus or minus, right? But you can't have negative side lengths in triangles like this, so you want to use just the positive answer. So it's about approximately 849. If you were to break this down, this would be 6 root 2 because it's 36 times 2. So if I ever ask for exact answers, the square root of 72 breaks down into 6 root 2, 36 times 2. So that would be 8.49 for the side lengths. Again, if you're given two angles, use the 180 rule to find the third. If you're given two sides, use the Pythagorean theorem, a squared plus b squared equals c squared, to find the third side. So how do we go about finding the angles then? Well, you want to use the given information, okay? So to find x, I'm going to use 7 and 11, okay, not the 8.49. So try not to use the values that you found in case you messed up. So let's say I square rooted wrong and I got the wrong answer. I don't want to, when I set up my next few equations, I don't want to use a value that I found. I want to always try to use the numbers that were printed on my paper and given to me. All right, so let's say I want to find x, okay? If I want to find x and you want to use the 7 and 11, that's going to be opposite over hypotenuse. So that's going to require sine. So to find the value of x, degrees, right, that angle, I'm going to use the sine of x equals opposite over hypotenuse. Take the inverse sine of both sides, sine inverse. Oops. Remember, my computer spazzes out sometimes. Give me just a second. Okay, so take the sine of both sides. Okay. My computer had a little bit of a brain fart. Okay, so sine of x. One second, let me see if I can get it to stop doing that. Okay. Beautiful. All right, so remember to cancel sine, you have to use sine inverse. That leaves you with x as an angle is the sine inverse of 7 over 11. 7/11. So what is the sine inverse of 7 over 11? Well, it's approximately, squiggly equal sign, 39.5 degrees. Don't forget your bubble. So from the point of view of x, 7 is opposite from it, and 11 is the hypotenuse, right? Now I'm going to set up an equation from the point of view of y. Okay, now I'm going to use the point of view of y using the 7 and the 11, okay? Well, the hypotenuse is always going to be the hypotenuse, guys, but depending on your point of view for the other angles, right, the other two angles besides the 90 degrees, you have to ask yourself, is it opposite or adjacent? So opposite and adjacent change depending on which angle you're looking at. The hypotenuse never changes because it's always across from 90 degrees. So if I'm going to find y and I need to set up an equation, then I'm going to be using adjacent, not opposite, okay? Adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So cosine of y equals adjacent over hypotenuse. So I'm still using the 7/11, but I'm not using sine anymore because the 7 is next to the angle y, not across from, not opposite, okay? Cosine inverse, both sides. Make sure you're showing your work, please. Okay, and then type cosine inverse into your calculator, and you should get approximately 50.5 degrees. Now, it's not a guarantee, but remember the three angles, so it's possible you messed up on your rounding or you did something else that might have been wrong, but these two angles, right? And the 90 degrees should add up to 180. So that's one way that you can kind of check to see, like self-check and see if you were on the right track. All right, guys, so again, don't stop until you have found all the missing pieces. In this triangle, we were given two sides. So that's two sides and the 90-degree angle. Remember, the 90-degree counts as given information. So they gave me three things, so my job was to find the three other missing pieces. You have to kind of use everything in the toolbox. Pythagorean theorem, the fact that three angles in a triangle add up to 180. If you're finding angles, you're going to use inverse trig functions, right? But again, remember that adjacent and opposite depend on what angle you're using. So the hypotenuse never moves, and it's always a hypotenuse in a triangle, but opposite over adjacent depends on which angle you're looking at. All right, guys, as always, if you have any questions, feel free to reach out, and we'll be happy to help. Enjoy your day. See you later.